5. Equations, tables, and graphs. I can generate different representations of the same data.
Awesome. So we have equations, tables, and graphs. If I give you an equation, you should be able to spit out a table and a graph. If I give you a table, you should be able to spit out the equation and the graph for that table. And if I give you a graph, you should be able to spit out a table and an equation for that graph. Yes, no?
Yeah.
Okay, so let's see how we did that. Slope and y-intercept, arguably, are the two things you need to know the most. Yes, no? As a matter of fact, that's the only two things you're really solving for in this whole thing. What is the slope? What is the intercept, or the y-intercept? Now, this is all review. You all understand what y is? The new learning that we had is y is also f of x. So if you see f of x, you're like, oh, it just means y. It's just the output. X. Hey, you just want to come on in. Nothing really new in x. M, we had some new stuff for m. So it's a slope, it's a sequence of a line, it's rise over run. Then we went down to number 6 and we said, what are some new representations of m? This, this means change in y over change in x. Take a y coordinate, subtract a y coordinate. Take the corresponding x, subtract the corresponding x, and you got slope. I'm kind of talking when you got something coming out. And then remember the y-intercept is where x is 0. So number 3, we'll go to the next page. Table to a graph. So I gave you, this is not it, is it? I gave you a table. So this is the table I gave you, and you needed to produce a graph. So you plotted the points, yes, no? And then you, I gave you a table, you need to produce a graph, and then slope intercept. So we plotted the points, we drew a graph right here, and then using the graph and using our table, we produced y equals mx plus b. Yes? B is always where what? Everybody.
X is 0.
So b, the negative 1, is where x is 0. So x is 0, y is negative 1, and then the slope is a rise of 1, a run of 1, a rise of 1, a run of 1. So the slope was what? 1. Or the slope would be the change in y over the change of an x, right? So let's go from this y to that y. What is it? What's 2 minus 1?
1.
Okay, well, let's go from this x to that x. What's 3 minus 2? So we've got 1 over 1. What's our slope? 1. We got that? Okay. The next thing we did is I gave you a line. I gave you a graph line, and you needed to write the slope-intercept. Okay? So all we needed to calculate was, what is the slope? What is the y-intercept? So from here to here, the slope was a rise of
3.
and a run of. So just to double check it, rise of,
3.
run of 1. So our slope is 3 over 1. And then where is this line crossing the y-intercept?
5.
0, 5, right there. Yes, no?
Yes.
And then the last one we did is what I think we've been doing the most. I gave you this equation, and you needed to graph it. What do we start with when we graph an equation like that, everybody?
Y-intercept.
So we started with the y-intercept. Did it move? No, it didn't move. The y-intercept was negative 4. So I think Anna did this.
No, I did.
Who's I? Oh, Natalie did that? Sorry, Natalie. She plotted negative 4. And then she used negative 3/2, which is our slope. So she went down 1, 2, 3. She ran 2. She went down 1, 2, 3, and ran 2. Which you can't see because I haven't moved down that far. Question.